Good morning or good afternoon. We're talking about week 4, day 1. We're continuing with partitions today, so 1.3 partitions and day 3. 1.3 coordinate geometry, day 5. So just as a reminder, day 1 was the distance formula. Day 2 was the midpoint formula. Day 3 was our first day of segment partitions, where our answer produced a point made of integers. Day 4 of coordinate geometry was segment partitions, and on that day we could have answers that were decimals. And then today is day 5, and we're going to look at our last day of segment partitions. This is actually the last new content before you take your test on Wednesday. So tomorrow's assignment will be a review, and Wednesday you'll be taking your test. So we're going to calculate the coordinates of a point using a given ratio. Now that's a little different than the last 2 days of segment partition because you've been given the fraction. What's the fractional part of an entire length? So today we're wording it, what does dividing a length by a ratio of 2 to 5 mean in the form of a fraction? Now we're used to ratios and fractions from previous classes where if I said the ratio was 2 to 5, you would just give me the fraction 2/5. That is not what's happening here, and that is because of the wording of the question. So if we look at it, here is our segment that has the point, because remember we're going to be placing a point somewhere along the entire segment. Now this says it's in a ratio of 2 to 5. So what that means is we're going to divide up the segment equally so that 2 of those pieces are on the left of the point and 5 of those pieces are to the right of the point. So how are we going to make this into a fraction? Remember, fractions are always the part you want to the whole thing. So what do we want? We want 2, and you can see right here that we want 2 because that's our first number. So we want 2 of how many? Well, not of 5. If you look at this entire length, it's 7. And the quickest way to do that is simply to add the 2 numbers together. So 2 plus 5 is 7. So the ratio of 2 to 5 is going to be equal to the fraction 2/7. So we'll be looking at the fraction 2/7. Okay, so how does that apply to partitions? So this is an example 0. So for those of you that are following along on the fill in the blank notes, this one is not on there. If you are doing your own notes, you can add this if you want, but you don't have to. This is simply to follow along. So line segment AB has endpoints 6, 7, and -3, -5. What are the coordinates of the point that divides the length of AB in the ratio of 2 to 3? So you'll notice that the wording on this question is slightly different, and that is because this is the type of wording that you would see on this state test. So we've kind of been building you up to this point. So you'll notice that they type out the word line segment instead of putting the segment symbol. And you'll notice they did not identify what is A and what is B. So what you want to know is that since A is listed first, the first point is point A. Since B is listed second, the second point is point B. So what are the coordinates of the point that divides the length of A to B in the ratio of 2 to 3? The only step that we're adding today is the conversion from ratio to appropriate fraction. All the other steps are going to be identical. So the first thing we're going to do is we're going to take that ratio of 2 to 3 and we're going to turn it into the fraction 2/5. So this is really asking what are the coordinates of the point that is 2/5 the distance from A to B. So we're going to be using 2/5 for our fraction. So other than that one step, this is exactly like it was last week. Next step you're going to do is you're going to graph the segment, making sure to appropriately label the endpoints. Remember, the first point is point A, and the second point is point B. So 6, 7, -3, -5. Then we're going to make that right triangle. Now again, you can do it above or below. I went ahead and just did mine below. And so your segment AB is the hypotenuse, and then you have a horizontal and vertical leg that you're going to draw in there. Number 4, you're going to use the horizontal and vertical legs to actually calculate those lengths. So again, you can count them, or you can use the distance formula and just subtract them. So 6 minus a -3, or you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. Horizontally, that is 9. Vertically, again, you can subtract 7 minus -5, which is 12, or you can count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry about the jump there. So if you need to pause the video to get caught up, please do so, because you should be taking notes all the time, even if it's on your own paper. But again, there are fill-in-the-blank ones that you can use instead. So this is the same diagram that we just had. I just can't get it all on the same sheet. So after you count the horizontal and vertical measures, now you're going to do the calculations. So this is where we're going to multiply. So we're going to multiply the horizontal distance by the fraction. Now remember, the fraction is 2/5. 2/5. So 2/5 times 9 is 18/5, or 3 3/5. But most of you, again, are going to want the decimal, which is 3.6. Then we're going to multiply to get the vertical distance. So vertically it was 12, but again it's 2/5 of 12. So 2 times 12 is 24. So 24/5 equals 4 4/5, which is 4.8. From the black here to the black here, you could just put it in a calculator. You don't have to do these intermediate steps, but I wanted you to see them. Okay, so remember, I like to circle these. So 3.6 and 4.8 are what I'm going to be working with. Now I need to make a decision which direction I'm going. Now, A was listed first everywhere in that question, so that's where we're going to go from, is point A. So from point A, we're going to be going left and down, left and down. So you can see this arrow is pointing to my left, but it's also pointing down. So from point A, which is the ordered pair 6, 7, we're going to be going left and down. So now that we know, we're going to add or subtract horizontally and add and subtract vertically. So remember, horizontally is the X value, and since we're going down, we're going to subtract 3.6. Vertically, we're going down, so going down is to subtract, so we're going to subtract 4.8. So left subtract, down subtract, giving us a point of 2.4, 2.2. Remember, the last thing you should do is graph the point. You need to plot it, because if it does not end up on our segment AB, something went wrong. So here's 2.4, so it's just short of half, and then 1, 2, and then just up a little bit, and so it's going to be right there. So there you go. The ordered pair 2.4, 2.2, and it ends up on our segment. Again, please pause the video if you need to get caught up, or watch it again. Feel free. Okay, our first official example that should go in your notes, either you are doing them on your own or you're using that fill-in-the-blank one. If you need to pause this to go get to fill-in-the-blank one, please do so. Okay. So the question is, line segment AB has endpoints -9, 4, 3, -2, What are the coordinates of the point that divides the length of AB in the ratio of 2 to 3? So just a reminder, line segment AB would normally have a segment symbol over the top. They just typed it out. The first point mentioned, which is point A, is the first coordinate. The second point B is the second coordinate. It says, what are the coordinates of the points that divides the length of AB in the ratio of 2 to 3? So that's telling me that I will be going from point A. Everything that's listed first is where I'm going from. So it says convert ratio to fraction, and then it says graph the segment. To be very honest, these two are interchangeable. I just like to do the converting first so I don't forget to do it. So the ratio is 2 to 3, but we're going to cut a length into a ratio of 2 to 3. We need to talk about how that cuts a segment into parts. So we're going to turn it into a fraction by adding 2 and 3 together to get 5. So our fraction is 2/5. So we're going to be using 2/5 for this question. Now I'm going to graph the segment. So -9, +4 for A, and +3, -2 for B. So there's segment AB. Go ahead and pause the video as you need to go ahead and get these things accomplished. So now we're going to make the right triangle. The purpose of the right triangle is to find out how long each leg is, because remember, this is based on the Pythagorean theorem, as so the distance formula as well. Okay. Now it doesn't matter if you do it above the triangle or below, but since I already know I'm going from point A, I'm going to go out horizontally to get in line with B, and then go down vertically to get to B. Horizontally, I'm going to count, or I'm going to subtract. So I got 12. Vertically, I'm going to count, or I'm going to subtract, and I'm going to get 1, 2, 3, 4, 5, 6. I'm going to get 6, and I'm going to record those on my graph. Okay, again, pause the video if you need. Now we're going to do our calculations, but remember, our calculations are based on 2/5. So horizontally, we're looking at 2/5 of 12, so 24/5, which is 4 4/5, which is 4.8. Vertically, we're looking at 2/5 of 6. So 2 times 6 is 12, so 12/5, 2 and 2/5, or 2.4. So when you're showing your work, you would just need to do the part that's in the black, the conversion, the multiplying, and the final answer. So you could just go from here to the decimal using a calculator. I just want you to see these. Okay, so we already know that we're going to go from point A. So let's make a decision. Is that right or left, up or down? So from A to B, we're going to the right. That's headed to the right, but it's also pointed down. And so when I put in my legs, that kind of helped me decide that as well. I had to go to the right to get in line with B, and down to get to B. So right and left. So, or right and down, excuse me. So from point A, which was -9, 4, we're going to go right and down. So right is addition. Right horizontally is we're going to add 4.8. And we're going to go down vertically. So down vertically, or down on the y-axis, is 2.4, so minus 2.4. So -9 plus 4.8 is -4.2. 4 minus 2.4 is 1.6. So I'm going to go to -4.2, so just past it, and up 1.6, so just past half. And there's my point. -4.2 and 1.6. Okay, again, please pause the video, rewatch it as much as you need. Okay, so here's our last example. So you can either graph it first or convert it first. This time it's called line segment CD, and it has endpoints 2, 8 and -6, 4. What are the coordinates of the point that divides the length of CD in the ratio of 3 to 7? So remember that point C is the first point mentioned, and point D, whoops, is the second point mentioned. That was not particularly lovely, but there we have it. So we need to convert 3 to 7 to a fraction, and we need to graph the segment. It doesn't matter which one you do first. Again, I'm going to convert first. So my ratio is 3 to 7. So 3 plus 7 is 10. So my fraction that I want is 3/10. I'm now going to graph point C at 2, 8 and D at -6, -4. Making sure that I'm labeling my endpoint. So draw the entire segment, please. Okay, so now we need to figure out how far it is horizontally and vertically. So we're going to draw our right triangle. Since I know I'm starting from point C, because it's the first letter mentioned, that's what I'm going to do. Horizontally, I'm going to get in line with D, and then I'm going to go down to D. So there's my right triangle. So segment CD should be the hypotenuse. Okay, so we're going to find out how far it is horizontally by either subtracting 2 and -6 or counting, but it's 8. We're going to figure out how far it is vertically by either subtracting 8 and -4 or counting, and that's 12. And now we need to do our calculations with 3/10. So horizontally, it's 3/10 of 8. So 3 times 8 is 24. 24/10 is 2.4. Vertically is 12. So 3/10 of 12 is 36/10, or 3.6. Please pause the video or watch it again. Remember that you're multiplying by 3/10. So we're going to start from point C. We need to figure out what direction we're going. So if I drew this right triangle to help me, then I notice that I went left and down. So from point C, which was 2, 8, I'm going left and down. So I'm going to be subtracting 2.4. So 2.4 is the horizontal. So 2 minus 2.4. And then I'm going to subtract 3.6. So 8 minus 3.6. So my answer is the point -0.4, positive 4.4. So -0.4, so not quite to halfway. And then up 1, 2, 3, 4 plus 0.4. So it should be around there. I'm getting it there. Okay, there we go. So there it is. There's point P. Now you'll notice it never does tell us what we want to call the point that we're plotting at the end. I tend to call them P and Q. Please make sure that you're taking notes. Please make sure that you're doing this work on a separate sheet of paper. If you have any questions, email your teacher, request a Zoom meeting, whatever you need to do. There are other videos out there that you're more than welcome to look at as well. And again, this is our last section on this before you take your test Wednesday. Tomorrow will be a review assignment, so no video tomorrow.